Nicole, Skylar.
First day of class this week.
Oh, I'm waiting on you.
I just submitted it like 2 minutes ago. I thought it was going to rain one of those days. Monday, I thought it was going to rain on us.
Alright, pretty funny to me that it's a completely different day's video, and I picked the exact same problem. I mean, out of all the problems in the book to pick from, I picked the exact same one, and it's a different day. You can watch them both. I got on a different shirt. It's crazy to me. But Seth noticed it real quick. I saw Kaylee whispering about it, so a few of you noticed.
How did what with it? I didn't know if you knew or
Alright, my first step in isolating the variable that I'm solving for k and getting a k all by itself is to get rid of what's being added or subtracted to it. So it's got a plus 3b there on the end. So I'm going to subtract 3b from itself and from the other side. Now on the other side, what's m minus 3b? I don't know. It's just m minus 3b equals, bring down my 2k. I got rid of that. Now I'm trying to get the k all by itself, and it's got a 2 in front of it. It means it's being multiplied by 2. So I'm going to undo that by dividing by 2. So over here, what's m minus 3b divided by 2? I don't know. It's m minus 3b divided by 2 equal to, over here my 2's canceled out, equals to k. Am I done? Have I solved it for k? Yes. Some people like to rewrite it with the variable that they solved for first. So you could rewrite it and say k equals m minus 3b all over 2.
Alright, so we're looking at linear equations again today. The actual title in the book says applications of linear equations. That just implies that we're going to get into some word problems. Look at your bullets over there. We got several bullets, but it's not very difficult or lengthy to look at. So first thing we have there is translating from words to mathematical expressions. I'm just going to give us 3, so I've got to write them out in words. I'll get them written up here, 3 of them, and then we'll talk about how to translate them into mathematical problems. First one says twice a number. We've got twice a number decreased by 3 is 42. There's number 1 that we're going to look at. Number 2 says the product of a number and 12 decreased by 7 is, yes, 42, is 105. And then the third one we're going to look at says the quotient of a number and the number plus 4
Is that little symbol an and symbol, like by the number?
right here, yes, that's it. And the number plus 4 is 28. Alright, so we'll rewrite those into some mathematical expressions and equations. So what's this?
no, on the third one.
The quotient of a number and the number plus 4. That's madness. Alright, so just have to do some reviewing over some practicing with words. These are obviously not all the words. You know, you got sum, difference, product, quotient, increase, decrease, twice, multiplied by 3, divided, ratio. There's all kinds of words that we could use on this. But number 1 says twice a number. Anytime it says a number, that's where you get to pick your favorite letter. You're going to use whatever variable you want. I'm going to stick with X's for the majority of the time today. But that's your freedom. You can use a C if you like C's, or a B if you like B's. But I'm going to stick with X for right now. So when it says twice a number, I know I'm going to use an X. Now, what does twice mean? Multiply by 2, right? So I've got 2 times X Okay, there's the first part up into the comma, twice the number. Now it says decrease. What does that mean? Subtract. So decrease by 3. If I pause right there, what have I written? Is that an expression or an equation so far?
Expression.
So far it's just an expression, okay? Because there's no equal sign in it. Remember, I'm doing bullet number 2 of note number 3, bullet 3 over there. I'm distinguishing between expressions and equations. So far I'm on expression. But if I keep reading the rest of the problem, it says decrease by 3 is. There's your equation word. Is means equal. So equals 42. Okay, all I asked you to do was to write it mathematically. We just did. We know how to solve that. We're not going to solve it right now. We're just rewriting it. So that would be rewriting it using mathematical expressions and equations. We wrote an equation ultimately because it ended with an equal sign in it. Okay, number 2, the second one. The product of a number and 12. So I'm going to have a letter with a 12 somewhere, but what does product mean? Add, subtract, multiply, divide. Multiply, product is the answer to a multiplication problem. So I've got my number times 12. Most of the time we just write that as 12x, right? So the product of a number and 12 decreased. You told me on the last question what decrease meant. Subtract, decrease by 7. So there's an expression. But keep reading. Is turns it into an equation. Is 105. Okay, everybody can do that? Alright, on the third one, that says you need me to interpret that chicken scratch says the quotient of a number and the number plus 4 is 28. So quotient, what does that mean I'm going to be doing? Dividing, very good. So the quotient of a number and that number plus 4. Did you see that? We had to use the X again because it said and that number is 28. So that would be our mathematical equation on that one. Yep, I like it. Get those right. Alright, not going to give you a whole lot of problems talking about the difference between expressions and equations because we've done that earlier in the week. We did it again just now, so we can mark the first and the third bullet point off. So look at that second one there, writing equations from given info. That just means I'm going to have a word problem. I got to be able to read it and get the math out of it and then work it. Okay, so we'll do some of that together. And this is harder to do together because I have to read the problem to you and make notes as we go. But this first one we got here, it says the length of the rectangle. So I immediately stop and I want to see my rectangle. So I'm going to be working with a rectangle. It says the length of the rectangle is 1 centimeter more than twice the width. Okay, these are common types of problems. The length of the rectangle is 1 centimeter more than twice the width. So if my width, I don't know it, is just W, the length is 1 centimeter more than twice it. Okay, see how we did that? 1 centimeter more than twice the width. Could you do that? 1 centimeter more than twice the width. Okay, then it tells me that the perimeter of the rectangle is 110 centimeters. Okay, so we got to figure out what the length and the width is now. Alright, so if this is W and I'm on a rectangle, this is also W. If this is 2W plus 1, this is also 2W plus 1. Perimeters you just add up all the way around. Okay, I'm going to write it a little bit differently. I'm going to W and W there, I know I have 2 W's, right? Plus, I also have 2 of these. So instead of writing them out twice, I'm going to just write 2 times it. You could write them out twice, you'll get the same answer. Okay, I said it equal to 110 because that's what they told me the perimeter was. Now, I need to do something here. For just the basic equation stuff, what do I need to do here? Good. So bring down the 2W. Gets me 4W plus 2 equals 110. Yeah, but let me do something before that. It wouldn't be wrong to do it now, but I want to do something before that. What do I want to do before I subtract the 2? Good. Combine those W's, what Joe and Chris are telling me. So that gets me 6W plus 2 is 110. Now I'm going to go ahead and subtract the 2 that they were talking about up front. gets me 6W is 108. So how do I find out my width? Divide by 6. Anybody got it for me? So my width is 18. So that means both of those sides are 18. So these are 2 times that, which is 36, plus 1. Those are 37. So I could say to write my answer, my width is 18 centimeters. My length is 37 centimeters. I'm not the best about always remembering my units, but if it's a word problem and you've got them, you need to get in a good habit of putting them on there. Luckily for y'all are to the point now, other than I don't know what your college algebra teacher's preference will be, but like ACT, if you take that again, or that kind of stuff, everything's going to be multiple choice. So, the only thing they could do I guess they could put 18 centimeters as a choice and 18 inches as a choice, to see if you really read the problem or not. That would be mean, but.
Yeah. They do it though.
Yeah. Lady be in trouble.
They do it.
Alrighty. Let's do another one like that, and then we'll get to the percent and stuff, those last 3 bullets. Let's do another one like that. It's not a rectangle, though. It's a baseball question. It says, 2 outstanding Major League pitchers in recent years were Randy Johnson and Johan Santana. In 2004, the 2 pitchers had a combined total of 555 strikeouts. Okay, so together they had 555 strikeouts. Johnson had 25 more strikeouts than Santana. So however many strikeouts Santana had, Johnson had that many plus 25 more. Okay, so I let S, my S's look like 5s, be careful. I let S stand for Santana, then Johnson was Santana plus 25. Okay, so what do these 2 guys over here, these 2 expressions that I've written, what do they have to add to? 555, right? The total strikeouts. So Santana plus Johnson, which is Santana plus 25, has to equal 555. Okay, now like earlier, we got some like terms over there. It's 2S plus S gives me 2 of those S's. Trying to be careful with 5s and S's. Making my 5s look funny. Alright, there's your middle school equation. What do we do first?
Subtract from 5.
Somebody pointed that out. 2S is
So
equal.
glad I'm here, right?
Every day I miss you when you're going golfing. 530.
And then divide by 2.
And then divide by 2. And Santana had 216 or 26. What'd you say? 265. So Santana that year had 265 strikeouts, which means Randy Johnson had 25 more than that, which would be 290. That's Zane, who did Santana play for? Do you know? It's weird to me because I watch baseball a lot, and I mean everybody knows Randy Johnson, but I've never heard of Johan Santana.
Santana played for
Mets. Joe knows
the
Mets.
New York Giants.
Mets is what Joe said. And I don't think that it's the New York Giants unless you're in football.
Where are you in
That's how much I know about baseball.
San Francisco Giants, New York Mets, New York
And he
Yankees.
played for
Surprise that we Alright, those are easy, just making sure you get them set up correctly. Now, percent problems. We did percent problems a little bit yesterday when we looked at part over whole. Remember that? Another way of saying that, what I'm going to use today, is my is over of is equal to percentage. Okay? So I would write this down today, and I know that looks funny. You're like, what the heck is over of? I'm going to show you. Is over of is equal to percentage. That's just a shortcut that I've learned that's always helped me, but that written down, and we'll use it in a minute. We're not going to use it right off the bat. All right. Are you ready? Percentage. In 2002, there were 301 long distance area codes in the United States. Okay? Which was an increase of 250% over the number of area codes in 1947. So we are asked to figure out how many area codes there were in 1947. So that's my unknown. So my X is going to be the number of area codes in 1947. That's what I'm trying to figure out. But I know that 301 is 250% more than that. Okay? So, if I had, first off, that 250% is kind of tricky because we're used to percentages being less than 100. And most of the time they are, but when you start talking about things growing a lot, that's when it gets to be bigger than 100. We did exponential growths in Algebra 2, and that would be something that's bigger than 100. But I do need to take that 250% and convert it to a decimal. And that's tricky because it's bigger than 100. What would 250% be as a decimal? Very good, 2.5. Okay, Lisa, I'm going to be using 2.5. Now, if I take 250%, 2.5, and I multiply it by the number of area codes in 1947, that's going to give me a start. Okay, I've got 250% times the number of area codes in 1947. But I need to add, what do I need to add on this? To set my, No, that's going to be equal because that's my total. It's going to be equal to 301. But I've not, this is the number of area codes, the percentage of area codes now. What I'm missing is number of area codes in 1947. So I got number of area codes in 1947, and it wasn't now, it was 2002. Number of area codes in 2002 for my total of 301. Alright, so what is that? 1x plus 2.5x will get me 3.5x. Just got a one step to solve that. So in 1947, that tells me in the U.S. there were only 86 area codes. Somebody in freshman will know if that's true or not. I mean, I don't know. It doesn't tell me where they got. Well, it does say source South SBC telephone directory. So they did get that from
I bet
somewhere.
there's more.
In 1947, I don't know. I mean,
No, I mean right now there is, I bet.
I don't know about that either because people now have cell phones that work on any area
Oh,
code most of the
yeah.
time. But anyway, I remember watching Andy, when you watch Andy Griffith and they want to make a phone call, they pick up their phone and hit the tapper until the operator gets on. They tell the operator who they want to call and they got to plug a wire in for them.
Andy.
Crazy stuff.
My dad loves that.
Yeah.
He
Ah.
does still.
It's a good show.
TV Land.
Yeah. I watch Bonanza off of TV.
You watch Bonanza?
Every day.
Brady said,
Gunsmoke? Gunsmoke?
No, I used to.
You're not a smoker?
I used to watch
oh
Gunsmoke.
my
I'm a
gosh.
smoker. Bonanza's my favorite though.
Yeah, that's how I go home. Alright.
He's a softie.
This one is just going to give us some basic info. This is where I'm going to show you how to use that is over of thing that we wrote a second ago. It says 187.5 is 125% of some number. What's the number? Alright, so this is where we're going to use what I wrote a second ago, where is over of is equal to the percentage. So what that is over of is just a shortcut when problems are written that way. My is, look in the problem that I gave you, is next to the 187.5. Now some smarties will say, yeah, but it's also next to 125%. Well, the percent goes in the percentage place. So the percent's never going to be your is. So is, my is here, 187.5 will go on top. Of some number, I heard somebody say a second ago, that's your x. That's what you don't know. Okay, now when I set this up, equals 125%, the way I do this, what are all percentages based on, even if it's bigger than it? No. Say it again, like say 100. So it's going to be 125 out of 100. Okay, I just made a proportion, didn't I? How do we solve proportions?
Cross multiply.
Boy, so I got 125x is equal to 18750. Let's divide by 125. And what was our x? 150. Is that all right?
My calculation's back
Well, it must be. Miss Brady's calculations back it up. Now, yesterday when we did part over whole, we talked about how the part's usually smaller than the whole. This is a case where it wasn't. Because my 150 would go on bottom there in the x spot, right? 187 is bigger than 150. Reason that happened is because we had a weird case where our percent's bigger than 100. So that's able to happen when it's in those weird cases where your percent's bigger than 100. Alright, so we did some percents. Let's do some investment problems. At least one. When I get into these investment problems and mixture problems, I'm usually going to make some kind of a little table because these are harder for me, so it keeps my stuff more organized. Says after winning the lottery, congratulations, we just won the lottery. After winning the lottery, we've got $40,000 to invest. So I don't know if that's everything we won or if that's after we paid our taxes. I don't know, but I'm happy with it. We've got $40,000 to invest. We're going to put part of that money in an account that pays 4% interest. Okay, so let me, I'll just keep reading it and making some notes and then we'll make our table. We're going to put the remainder of the money into stocks that pay 6% interest. Our accountant tells us that our total annual income from those investments is going to end up being $2,040. How much did we invest at each rate? Alright, so I'm going to have money. We always call that principal. That's what you put down. Principal. And then our rate. And then our interest. Alright, so we'll start here with 4%. How much money am I putting at 4%? I don't know, right? That's what we're trying to figure out. The rate, if it's 4%, is the same as 0.04. To get interest on that, all you do to find interest is you multiply principal times rate, so that would be 0.04x. Okay, my other rate is 6%, so I'm going to put that down there next. Now, how much am I putting now in that? The rest, and I started with $40,000, so it'll be $40,000 minus x, because I put x on 4%. Okay, so to get the interest now over here, I have to multiply that 0.06 times both of those. So it's distributed property. So what's 0.06 times $40,000? $2,400, and then minus 0.06x. Okay, so I'm making 0.04x on that one. I'm making 2,400 minus 0.0x on that one. I know the total interest I'm going to make is 2040. So shouldn't I be able to add these and then equal 2040? Yep. 0.04x plus 2,400 minus 0.06x equals $2,040. Alright, looks funny in the beginning because you're going to get some negatives and you think you can't have negative money, and that's right. It'll end up working out in the end, so don't give up on it yet. What I'm talking about, when I combine these like terms here, 0.04 and 0.06, negative 0.06 is negative 0.02. But now my next step is to subtract that 2,400 once you, so that's going to be where my negatives will end up working out. Because now I got negative 0.02x equals, what's 2040 minus 2,400? Negative 360. So you got a negative divided by a negative, which gets us back to a positive, so it's all good. How much money is that, Zane? 1,800 or 1,000? 18,000. So at 4%, we make 18,000. How much we invested 18,000, excuse me. How much did we invest at 6%? All the rest of it. So 40,000 minus 18,000 would be what? 22,000. So So there was how much we invested at the two different ones. Alright, now I gotta do a mixture problem, and I kind of been in fast forward mode a little bit because I wanted to get all of Brady that I could. So let's do a mixture problem real quick. I'm not a fan of mixture problems. I don't know. I don't know. I think Mr. Algebra ought to be the one to do these problems. We've got a chemist who must mix 8 liters of a 40% acid solution with some 70% solution to get a 50% solution. How much of the 70% solution should he use? So the 40% solution, we've got 8 liters of it. The 70% solution that we're going to mix with it, we don't know how much we need to use. It's going to end up being a 50% solution. It's going to be a mixture of that 8 plus that X. Okay? So I'm going to make me a little chart here. I'm going to have my number of liters, and I've got an 8 and an X and an 8 plus an X. Then I've got my percent as a decimal. So I've got 0.4 went with an 8, 0.7 went with that X, and 0.5 went with that one. And I've got...
Teachers, pardon interruption. We need the homecoming escorts to go to the teachers' lounge to get measured for their tux. Thanks.
So let me finish this problem. I'll be good. Now to get my liters of acid, I'm just going to multiply. So 8 times 0.4. You know 8 times 4 is 32, so move your decimal. 3.2. X times 0.7. Good. Then this one, we need to distribute the 0.5 to both of those. So 8 times 0.5 will be 4, and then 0.5x. So if this one on the bottom was what our mixture was going to end up being, I should be able to add to equal. So I got 3.2 plus 0.7x equals 4 plus 0.5x. Okay, so now we got one of those 4 parters. You can pick which part you want to start with. So subtract the 0.5x, Mr. Small said. So that gets me 3.2 plus 0.2x equals 4. Subtract 3.2. So that gets me 0.2x equals 0.8. Divide by 0.2. What's 0.8 divided by 0.2? What was it? 4? It should be 4, right?
4.
Yeah. So what we actually found there, that's our answer. Let's go back and think about what we actually found. The question said how much of the 70% solution should be used. So we need 4 liters of that 70% solution. Okay? All right. Tomorrow, we're going to look at some inequalities. They got greater than, less than signs in them. So that'll be tomorrow, all right? All right, you tuxedos, go get measured.
See you, Coach Rock.
Have a good one.